Alright, on to part 2 of our video on using matrices for transformations, ladies and gentlemen. We've got a scenario here which is much more relevant to the exam style question that they will ask you. So this one I would take particular attention of, okay? So we've got here, for the transformation described by this, the transformed x and y, here's our transformation coding here in matrix form. We have to firstly find what is the image of the function f of x equals x plus 1 under this transformation. Secondly, we have to find the image of the point 2 and 3. And thirdly, we have to describe the type of linear transformation which applies. Okay? Now, these are really very simple, guys. I'll show you what to do. Part A. Now, we know that we've got going from this notation to this notation and then just decoding this matrix and writing it as two equations, one in x prime and one in y prime. We would know that x prime equals, let's go with it, 1 times x plus no times y, right? And y prime would be no x minus 1 y. Now this is what I call the key to everything, because it truly is the key to understanding everything with these transformations. Now what I'm going to do is I'm putting x and y as the subject of that key to everything set of equations, because what I'm going to do is I'm going to plug that x and that y back into this equation to get a new equation, a transformed equation, the image as they call it, okay? So if I let f of x equal y, which just makes things easier if I use a single symbol, y is equal to x plus 1, I'm going to plug x and y from the key to everything back into that original equation, and I get minus y prime equals x prime plus 1. If I just clean that up a bit, I get y prime is minus x prime minus 1. Now I can drop the dashes because I have my new transformed function, okay? So the image is y equals minus x minus 1. It's really that easy. The only dodgy bit is this matrix thing, which you can very, very quickly convert into simple equations which give you the key to everything, to unraveling the problem which we have before us, okay? Alright, part B, we've got to find the image of the point 2 and 3. Well, that is extremely easy because we have the key to everything. We know that x prime is equal to x and y prime is equal to minus y. So that's what we do. We just use that. We substitute x is 2 into the x prime equals x equation and we get x prime is 2. And we substitute y is 3 into the equation for y prime and we see that y prime will be minus 3. So therefore the image of the point 2 and 3 is 2 and minus 3. Easy as, isn't it? So now we have to describe the linear transformation which applies. Well, we know that x prime is x. We know that y prime is minus y. Well, come on, have a look. I mean, that's a reflection in the x-axis if ever I saw it. Yes? Of course it is. Okay, there it is. Well done, okay? Now this question is another question which you could very likely expect to be in an exam. It's a backwards transformation, as I call them, because what you are given is the starting function here and the finished transformation function here, and you are given this matrix code for what I call the key to everything, which is the relationship between x prime and x and also between y prime and y. But this is all full of pronumerals and we have to find out what the pronumerals are. In other words, we have to decode this matrix transform here and work out what the values of the pronumerals are and therefore what the steps are. That's what we've got to do. Now, it is a little bit challenging because there's completing of the square involved in it, but it is a very straightforward cookbook procedure, so I would suggest you take note because something like this could be in the exam and has been in the past. So, we've got the original function here, y equals x squared. We've got the transformed function here. You'll note the primes on the x's and the y's, okay? So, That's the first step. What we've got to do now is get these two equations in equivalent form so that we can then compare equivalent terms, the x equivalent terms and the y equivalent terms, and then get the key to everything, which is the relationship between x prime and x and y prime and y, and then we will have the values of these pronumerals here laid out before us as easy as pie. But the first part of it is to get them into equivalent form, and that's a little bit difficult. So let me show you. We've got this equation here. What I'm going to do is I'm going to try and get this into a linear factor squared, because to compare this equation with this equation on the x side, I really need that. This here is like x minus 0 in brackets all squared, if you like. And I've got to do the same sort of thing to here. I can't have an x squared term and an x term. It won't work like that. So I've got to do that little bit of surgery on it. So I'm taking out minus a quarter here, and I've got this inside the brackets, and then I'm going to complete the square inside the brackets. As you'll see, there it is. I've added 1 and subtracted 1. Now I've got my perfect square in these three first terms inside the bracket. I'm going to get rid of that minus 1 there, get it outside the bracket in the next line. There it is. It becomes plus a quarter when it's multiplied by minus a quarter out the front. Okay, we're getting there, guys. Hang on. So therefore we get that. Okay, now it's looking good now. Okay, this is almost in equivalent form compared to this equation here. Okay, next line. And therefore we've done a little bit of manipulating around the place. I've multiplied by minus 4 on both sides, and I've got minus 4 times y prime minus 2 equals x prime plus 1 all squared. Now that is in equivalent form compared to this equation here. Okay, now we're going to compare like terms now, equivalent terms. Therefore we're saying that this left hand side here is the same as the left hand side up there, and we're also saying that the right hand side, this one here is the same as the right hand side here. Now let's solve that for y prime and x prime. There we are, and there we are. Okay, so therefore we can see we've got the key to everything. Here it is, the relationship between y prime and y and between x prime and x, and we can look back up here and see that this says x prime is equal to a times x plus b times y plus e in its general pronumerally form, and also that y prime is equal to c times x plus d times y plus f. Okay, and I can just read what's down here and work out which pronumerals are what. There we are. That's what I get from the matrix transform, the coded key to everything, as I call it, up here. And then I can just I can look at the coefficients and work out what the pronumerals are. The equating coefficients, I can see that A must have been 1, B must have been 0, and C must have been minus 1. And also, looking at the y side of it, that C must have been 0, D must have been minus a quarter, and F must have been 2. Now I've got an NB here, guys. There's actually another way of putting this into equivalent form, and I've just done that in the lines that follow that NB statement. That involves basically taking this a quarter here and making it belong to the x, putting it inside the bracket with the x. And whilst it produces a different result in terms of all these pronumerals, it's exactly equivalent and in effect produces the same transform algorithm. Okay, but I'll just do it for the sake of completion. It doesn't matter which way you do it, all roads lead to Rome, as they say. Okay, so the equivalent form could have been expressed as I was just saying. Here we go. Okay, so now we'll put the quarter inside the bracket with the x prime plus 1 term. There it is. You see that? It's gone inside the bracket as a half. Right? Does it look right? Yes. Okay, and that produces a different equivalent form, because we would then say that minus y prime minus 2 would be this one here. Okay? And there's no 4 out the front as there was over here when I put it in equivalent form over here. Alright guys, now I can equate equivalent terms like I did before, and I will get that one there for the y side, and I'll get that one there for the x side, and putting y prime and x prime as the subject of those equations to get our key to everything. I get that for the y and that for the x, and now we can do the same process as we did over here, knowing that this is the generalized algorithm for x prime and y prime from our matrix coded key to everything, if you like, up here. Yes, we know that, and therefore we can just equate the coefficients and we would get that. Now they are different results, as you can see from up here, but as I was mentioning just before, they are entirely equivalent and therefore they are both correct. Okay? Now if you have a little bit of a cogitate and a reflection on that, and if you practice that and make sure you can do it, you'll be in a very good position for any future exam questions. Alrighty, thanks very much and we'll see you soon.